Hi, we are going to do 8M7 lesson 1. For those of you who've been paying attention and or at least were watching me in 8M6, I had thought that 8M6 was the end of the 8th grade year, but no, there's 8M7 and you have 23 more lessons. And I am so excited because now I get to teach those and I love teaching math. So let's get on with all right, so let's get on with it. Let's go learn about what 8M7 is all about. It is about the Pythagorean theorem and more. So what is the Pythagorean theorem? So let's do it again. So it says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So sometimes this English is kind of hard to parse out, but I've drawn a picture here and I'm going to help you parse the English. So we have this thing that says is equal to, so it sounds like what this is a formula. Let's see, the sum of, so there's an addition, the squares of the lengths of the legs. So if we square each leg, that's equal to something. So if we take this picture of a right triangle and we identify what the two legs are, a leg is the side is actually either of the two sides in a right triangle that are adjacent. That means touch the right angle. So here we have our right angle. So there's two sides that touch the right angle. That's our A and our B. And so those are our legs. Our legs are the two sides that make up the right angle. And so the other side, and so if we add together the squares of those lengths, that's going to equal the square of the hypotenuse, the length of the hypotenuse. So the hypotenuse is the side opposite, the side that doesn't touch the right angle. It's the side opposite the right angle. So that's the hypotenuse. Is the side opposite the right angle. And so that's our vocabulary. But we knew this because let's go back and let's just recall what we've done this year. In 8M2 lesson 15 A and B, we proved the Pythagorean theorem one way. And then in 8M3 lesson 3, we came back again and we, in a whole different unit, 8M3, we proved it another way. And then in 8M4 lesson 31, we actually went about a method using simultaneous equations, systems of equations to find Pythagorean triples. These are sets of whole numbers that can be the sides, can be the length of sides, to be technical, the length of sides in a right triangle. And so those are numbers like 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. And there's actually not a lot of numbers. Well, there are a lot of numbers, but most triangles, most right triangles don't work out in this neat pattern. But there are a number of them that do, and you can go back to 8M4 lesson 31 to find methods for generating these numbers that magically work. Okay, this lesson though is all about reviewing the Pythagorean theorem, making sure you know how to use it, then also finding the cases where we don't have whole numbers for sides, how to estimate the final side, the length of the final side. So we're going to go through those two things today. Review of the Pythagorean theorem with whole numbers, and then for Pythagorean right triangles that don't have whole numbers for all of the sides, how to estimate the final side. Okay, so let's look at these two examples here. And in these two examples, we have triangles that are Pythagorean triples. In other words, I'm telling you that these ones just work out to where the answer is a whole number. So let's find the missing sides in these triangles. So I would like you to pause and try. If you remember how to do this, if you remember how to use Pythagorean theorem, then I want you to pause and try these two examples. Otherwise, I will just go ahead and work them. So I assume now that either you've paused and tried these two on paper, or you don't remember how to do it, in which case we'll just solve them right now. So the Pythagorean theorem looks like this: a squared plus b squared equals c squared. And now a and b are my legs, and either leg can be a or b. So let's just mark those down here. So I'll just call this one a and this one b. If you flip-flopped these, it would be okay. Everything would work out. But it's really important that you know that this side opposite the right angle is C, because that one can't be, you can't mix and match C. C has to be the one that sits by itself. So let's plug in our numbers. So we know that 3 is A, so it's 3 squared plus B is 4 squared equals C squared. So let's simplify. The next step is simplify. So now we have 9 plus 16 equals C squared. So 25 equals C squared. So C squared has to equal 5, or C equals 5. Because 5 squared equals 25, right? So that would look like this: 25 equals 5 squared. That's the number that works. So C has to be 5. Let's do this one. This one's a little bit different. Let's write in our formula. Let's just do this one in blue so it really catches your eye. A squared plus B squared equals C squared. Now here I've changed it up a bit. We have, this is A and this is B, and then the side opposite is C. So here we don't have the two numbers on the left. We have one number on the left, 5 squared plus, and we don't know B. So you see how this one's different, equals 13 squared. So now we have 25 plus B squared equals 169. Now we have to do a little bit of different kind of simplification. Subtract 25 from both sides, and we get B squared equals 144. Well, what number squared is 144? And for those of you that said that it's 12, you are right. 12 squared equals 144. So B has to equal 12. So these are numbers, these are problems. We've done these before, but I just want to refresh your memory. And we did lots of these earlier in the year. So now let's move on to some examples where the numbers don't work out so nicely. So sometimes the sides are not whole numbers. So in these cases, we're going to estimate the other side. And I'm not going to ask you to pause and try because you may not know how to do this. So let's learn this together. So here we're going to still use the Pythagorean theorem. And we just have to label our sides. So the side that we don't know is C, but we do know B is 6 and A is 4. So let's go 4 squared plus 6 squared equals C squared. And so we get 16 plus 36 equals C squared. And so we get 52 equals C squared. Now we don't know what number squared is 52 because what do we know? Let's just write some numbers down over here. We know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Let's just keep doing this until we get past 52, and you'll see why I'm doing this here in a second. And then 7 squared is 49, and then 8 squared is 64. So this is our x, and this is our x squared. Okay. So let's see. So if this, now you have to, now here's where we're going to learn something new perhaps. So if C squared, let's see. So if C squared is 52, then C has to be between two numbers. So because we know it's not 6, because if C was 6, let's see. So let's do a little chart here. If C was 6, then C squared would equal 36. If C was 7, then C squared would be 49. And if C were 8, then C squared would be 64. So what does C have to be if C squared is 52? So let's put that 52, where does it go? It goes right here. It goes between 49 and 64. So C has to be between 7 and 8 in this example. Okay, because again, if C was 7, then 7 squared would be 49. If C was 8, it would be 64. So C has to be some number. Maybe it's 7.1, 7.2, 7.3, or 7.1 dot, 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 or 7.2 dot, dot, dot. But we know that C has to be a little more than 7, but a little less than 8. So I'm going to estimate in this case that C is between 8 and 7. Well, that's not an estimation. That's exact. We know that C is between 7 and 8. So I am estimating it may be 7.2 or 7.3, but C is between 7 and 8. And that's my answer to A. So the way that we find our estimations is we have to know our squared tables, and then we find the number, the C squared, the squares that it fits between, and then we know that the number C has to be between those two numbers. Let's do another one. This one's a little bit more advanced, but I'm gonna add a little bit of trickery here. So here's our A, and here's our B, and here's our C. Well, in this case, we don't know B and C, but I gave you like this kind of this little trick. I know I've told you that this is a 45-degree angle. And so for those of you who really recall your angle keys or your angles in your triangle formulas, you know that this has to be also a 45-degree angle, because that you know that your angles all have to add up to 180. So that if you do the math on it, this one has to be a 45-degree angle. So if this is a 45-degree angle and this is a 45-degree angle, then the sides opposite have to be the same length. So B has to be 7 also. So if you don't remember that, then just jump forward to this part of the problem and then we'll solve it from here. So B is 7 and A is 7. So now we're going to try and find C. Okay. Let's do this one in a different color. Let's do this one in orange. So now we have a squared plus b squared equals c squared. And we're going to have to estimate c squared because it's not going to work out perfectly. So we have a is 7, b is 7. We don't know c. So we have 49 plus 49 equals c squared. So that's 98 equals c squared. Now we have to do the same thing over here that we did on our previous problem. And we have to find some square numbers that fit around 98. So what if c squared is 98, then it's between two numbers. So, well, I know that it's bigger than 8, so let's put down our 8, and that's 64. And 9, we know, is 81. And 10 is 100. So now we found two numbers that are on either side of 98 for c squared. And that's 81 and 100. And so if 98 goes between 81 and 100, then we know that c has to go between 9 and 10. Because if c was 9, this would be 81. And if c was 10, it would be 100. But c squared is between 81 and 100. So c must be between 9 and 10. So we write that 9 is greater than c. Or 9 is less than c. c is bigger than 9. But c is also less than 10. So c is between 9 and 10. So let's give ourselves a nice happy cat. Where's happy cat? Nice happy cat for this problem, a nice happy cat for this problem. And we're going to move on to some homework help. And on homework help, we're going to do 3 problems. We're going to find either the exact length of the missing side or estimate it if it is not a whole number. Okay, so I'm not going to tell you whether the answer is a whole number or not. You're going to have to figure it out and then tell me whether or not it's an estimate or not. Okay, so on A, this should be straightforward. This is the way that we just did problems in the previous slides. C is the same. Now B, you're going to have to break this problem down. And so I'm going to give you a hint. And there's a problem on your homework like this. So break it down into this triangle first, this right triangle, and estimate this side. And then you can know something about the rest of the shape, and then you can estimate the whole side. Okay, so I want you to pause plus try these problems. Okay, I assume you're back, and so now we're going to do the Pythagorean theorem on these 3 problems. And I'm going to tell you, none of these are exact. All of these are estimates. Okay, so let's do this first problem. A squared plus b squared equals c squared. Hopefully you all, there's my right angle. Sorry, hopefully you all realize this is side C. And so we have a squared is 3 squared plus 7 squared equals c squared. We have 9 plus 49 equals c squared. 58 equals c squared. So if we do a chart, you don't have to do these charts if you don't want to, but I do them because I find them very helpful. I'll say, well, 7 is 49 and 8 is 64. So I know that my c squared is 58. This is my c squared. So I know that my c has to be right in here. Has to be between 7 and 8 because c squared is between 49 and 84 and 64. So we have C is less than 7 and is, 7 is less than C, which is less than 8. So C is between 7 and 8. So let's lay down a happy cat for that guy. And let's come in here and let's switch colors and do this next one in pink. Okay, so let's do C next because I think it's easier than this top one. So let's go, where's my A and my B? I didn't line up this triangle exactly the same. So there's my C because it's opposite the right angle. So don't let that throw you. Not everything is lined up perfectly. Not everything is always oriented exactly how you'd want it. But let's do A squared plus B squared equals C squared. And we don't know our B. So we got 25. I'm just going to go ahead and do the math all at once. 5 squared is 25 plus B squared equals 64. Well, let's subtract 25 from both sides. Oops, 5, 14, 9, 39. B squared equals 39. Well, I know, let's see, B and B squared. If I have 36 is less than 39, and that would be 6. If B was 6, B squared would be 36. But B squared is a little more than 36. So let's see, 7 is 49. So we've identified the two numbers that B has to be between, so that B squared is between 36 and 39. So my answer is B is between 6 and 7. All right, now let's go to the hardest problem, maybe the hardest problem. Let's see if it was tricky for you. Let's do this one in, what color should we do it in? Orange, no. Green, let's do green because we don't have another green here. So again, the way I'm going to do this, because I don't have a big right triangle. I just have two little right triangles. So I'm going to do this problem first. Here's a right triangle. So I know I can find this side right here. I can estimate it. And in this case, this would be my A, this would be my B, and this would be my C, opposite the right angle. So we have A squared plus B squared equals C squared. So we have 49, 7 squared, plus B squared equals 100. That's 10 squared. So if I subtract 49 from both sides, I get B squared equals 51. Good. Okay, so now I know that B and B squared, let's see, let's do our little chart. I know that what's a square number that's a little less than 51? That would be 49. So B would be 7 if it was 49, and greater than that is 8, 64. So 51 goes between there. So I know that B is between 7 and 8. Now let's look up here. So let's just stop there for a second, and let's look up here again. And let's see if 7. Let's look at this triangle over here. Well, this triangle is the same size as this triangle. How do I know that? Because I have a 10 over here and a 10 over here. And so I have also the problem, if this was A and this was B, I would have 7 squared plus B squared equals 10 squared. And that's the same problem. So I know that this is the same length. I could also know it's the same length because I have all of my angles. I could have looked at some of my angle theorems that we learned about earlier this year as well. But we don't have to worry about that because we look here and we say, hey, that's the same problem as over here. So B squared is the same. So over here, this piece is the same length as this piece. Okay. So that's B and that's B. So now I have to figure out what 2B is. Well, if I have a number that's between 7 and 8, and then I double that number, what does that number have to, what is the smallest that number could be? Let's pretend that B is equal to 7.0001. Well, 2 times B would be 14.0002. And what's the biggest B could be? Well, if B is equal to 7.9999, well then 2B is equal to just under, well, if we multiplied this number by 2, we'd find that it's equal to 15.9998 or something like that. If we multiplied that by 2, we could use a calculator and see that that number is just under 16. So the way that you can, another way you can do this is you can just say, well, we have this inequality here. I can just use my rule of my multiplicative rule of inequalities, and I could just multiply this by 2, and I could get 14. I could multiply this by 2 and get my 2B, and I can multiply this by 2 and I can get my 16. So 2B, which is this whole piece here, has to be between 14 and 16. In other words, think of any number between, another way to just think about this is any number that's between 7 and 8, if I doubled it, if I had between $7 and $8, let's just pretend in my pocket I have between $7 and $8 in my pocket. I don't know how much exactly I have, but let's say that someone said, well, whatever you have in your pocket, I'm going to double it. So you take out all of your money that's between $7 and $8, and he doubles it. What you're going to find is that you're going to have between $14 and $16 money, and then money times 2. So you can just think about that over and over again. But if I was to double the money in your pocket, you double the 7, you get 14, and all of the change that is less than $1, I doubled that. I'll never give you more than $2 for it, but I'll always give you more than a penny, or at least a penny for it. So you'll always have more than 7, but you'll never, sorry, 14, but you'll never have more than $16. Okay, so that's that lesson. That's lesson 1, 8M7, and we are going to be carrying through to 8M7 lesson 23, and that is the end of the 8th grade year. So thanks for sticking with me. Hopefully those homework problems were helpful, and we'll be jetting along and getting a little bit more advanced with every lesson as we go. Okay, happy cat, happy math.